Welcome back everyone to my channel Chemistry Made Simple for NEET, and this is Dr. Radha Subramaniam with you, and today we are going to continue with the remaining part of solid state chapter 1 NCERT Chemistry class 12. Okay, so before I move on with today's session, as usual many of my students are asking different questions regarding the NEET 2022 exam. So one question being, I have crossed more than 24 years of age, can I attempt for NEET 2022? Yes, of course you can attempt for NEET 2022. Candidate should be at least 17 years old to attempt the NEET exams, and there is no upper age limit for the candidates who want to appear for the NEET undergraduate test as per the decision taken by NMC, that is National Medical Commission. Upper age has been removed by NTA, those who want to appear for the UG NEET exams. Earlier the upper age limit was 25 for general category candidates and 30 for reserved category candidates. Okay, another question is, I am a student of open school education, can I apply for NEET 2022? Candidates who have passed 10+2 as private candidates or from open schools are not eligible to take the NEET exam. Okay, and next question is, can I appear for NEET exam even if I have a gap of 1 year between my classes 11 and 12? Yes, you can appear for the NEET even if you have a year gap. Earlier there was no rule regarding the gap years, but the Delhi High Court has made the amendments. Okay, and as you know, another question one student asked was, can I forfeit my candidature once I pay the application fee? Will I get a refund? No, you cannot forfeit your candidature. There is no option to do it. You will not get a refund if you do not appear for the exam. Okay, and also there are changes of course in the latest NEET exam pattern, and according to the new NEET exam pattern, each NEET subject will have two sections, A and B. Section A will have compulsory 35 questions, while B will have 15 questions, of which candidates need to attempt only 10 questions. And normally which type of questions usually are asked for the NEET exam? As you know, they are all MCQ types of exams. And so my another student was asking me, if particulars are incorrectly printed on the admit card, what should I do? If your particulars are wrongly printed on your admit card, then you have to contact the concerned authorities and get it rectified. You can mail the conducting authority at neetug-nta@nic.in. Okay, suppose one student was asking what to do if I misplace my NEET admit card. And you need not worry if you have misplaced your NEET admit card. You can access your admit card from the official website by logging into the candidate portal. And okay, and what is the optimum time to reach the examination hall? NEET exam usually commences from 2 p.m. onwards. Therefore, one can enter the exam hall 2 hours before the exam to make a hassle-free entry. And many students are asking, is there any dress code to be followed? Yes, candidates must follow the NEET dress code rules if they appear for the exam. For male candidates, it is ideal to wear light color t-shirts or half sleeved shirts. Kurta pajamas are not allowed. There should be no fancy pocket zips, then big buttons or even embroidery in your clothing, and mostly it is better to wear trousers and sandals because shoes are not permitted. For female candidates, wear light colors, avoid elaborate prints, embroidery, zips, sleeves, brooches, buttons and all that. Wear sandals and slippers which are low heel, and they are advised not to wear any jewelry or such accessories on exam day. Another question is, can I take water bottles inside the examination hall? No, candidates are not advised to take any food items or packed water bottles inside the exam hall. Okay, now we will get along with today's portions without wasting much time. So, I will be starting with a short key defect. And what is short key defects? Okay, normally in this model, what is being said is that short key defect, that is known as small short effect, is named after a popular German physicist Walter H. Schwarzschild, who was even awarded the Royal Society's Hughes Medal in 1936 for the discovery of this defect. So, in his model what he says is that the defect is formed in ionic crystals. See, ionic crystals means negative and positive charges. Oppositely charged ions leave their lattice places, lattice sites, which leads to the creation of vacancies. You can see here, see, vacancies are created, and these vacancies are further created to maintain a neutral charge inside the crystal, and the model also explains that the surrounding atoms also move to occupy these vacant spaces. When the defect is found in non-ionic crystals, it is referred to as lattice vacancy defect. Clear? Okay, now as I already told you, tetrahedral voids and octahedral voids, we discussed it in our last session. You can go back and see in detail. That is very important. And here in both HCP and CCP methods of stacking, a sphere is in contact with 6 other spheres in its own layer and directly touches 3 spheres in the layer above and 3 spheres in the below layer. So, the sphere, one sphere will have 12 close neighbors. Okay, so the number of nearest neighbors in a packing is called the coordination number. We showed that in the previous session also. You can just go and watch it again. In close packing arrangement HCP and CCP, each sphere has a coordination number of 12. Just remember that tetrahedron and this is octahedron. So, you can see tetrahedral hole and octahedral hole, and placing the third layer over the second layer. Suppose the third layer is placed over the second, there are 2 possibilities, like covering tetrahedral voids. Tetrahedral voids of the second layer can be covered by the spheres of the third layer. So, the spheres of the third layer are exactly aligned with those of the first layer. Okay, if it is like that, then the pattern of the spheres is repeated in alternate layer, and we often write it as CAB like that. So, this structure is called HCP or hexagonal close packed structure, and this sort of arrangement of atom is found in metals like magnesium, zinc and all that. See, hexagonal packing, HCP, CAB. See, correct alignment you can see here. See, regarding the spheres aligned identically. Okay, now covering the octahedral voids. See, the third layer may be placed above the second layer in a manner such that spheres will cover the octahedral voids. So, if you place it in this way, the spheres of the third layer will not be aligned with the first or second layer. So, we call it C-type alignment. So, the 3 layers will have different types of spacing, and only when the fourth layer is placed, the spheres are aligned, that is, the spheres of the fourth layer will be aligned with those of the first layer. So, this pattern of layer is written as ABC, CABC like that, and this is called cubic close packed CCP or face centered cubic structure, FOC structure. Metals like copper and silver crystallize in this structure. You can see tetrahedral holes, okay, octahedral holes. Okay, now next is packing efficiency in simple cubic unit cell. So, packing efficiency has a formula: volume occupied by all the spheres in unit cell divided by total volume of the unit cell into 100. So, A be the edge of the unit cell and R is the radius of the sphere. As the spheres are touching each other, A is equal to 2R, 2 times the radius. So, the number of spheres in the unit cell is 1 by 8 of 8, which is 1. Volume is 4 by 3 pi R cube, and that is volume of a cube is A cube, which is 8R cube. Fraction of the space occupied will be 1 by 3 pi R cube divided by 8R cube. You will get 0.524, remember that value. So, percentage, that into 100 will be 52.4% for simple cubic unit cell. Clear? Okay. Next is efficiency of packing in body centered cubic cell. In body centered cubic cell, that is in triangle AFD. See, AFD here, this triangle, AD is equal to A and DF is equal to B. You can refer to the figure. You know, ED and EF edge length will be the same A. Now, B square is equal to same A square plus A square, 2A square, and AF is C, as you can see in the figure, and FD is equal to B and AD is equal to A edge length. So, C square is equal to A square plus B square. C square will be A square plus B square, right triangle. Okay. So, that is 2A square A plus 2A square, 3A square. This is not 2A square, this is 3A square, or C is equal to root 3A. So, you know that C is body diagonal. So, the sphere at the center touches the sphere at the corner. So, body diagonal C is equal to 4R. Remember, root 3A is equal to 4R, or A is equal to 4 by root 3, 4R by root 3. So, volume of the unit cell is equal to A cube. Just take the cube of this, okay, and you get 64R cube divided by 3 root 3. Number of spheres in BCC is equal to 2. So, volume of 2 spheres is 2 into 4 by 3 pi r cube. So, packing efficiency will be equal to volume occupied 2 by 2 spheres divided by total volume into 100. So, 2 into 4 by 3 pi r cube, just substitute, divided by total volume you got as 4 by root 3 r the whole cube into 100, just calculate it. 4 2s are 8 by 3 pi r cube divided by 4 cube is 64, root 3 cube is 3 root 3 r cube percent, that is equal to 68%. Memorize this value because you won't get much time for calculation in your exam hall. Okay, packing in CCP and HCP. So, if r is the radius of the sphere and a is the edge length of the cube. So, 4 spheres in FCC. So, volume of 4 spheres is 4 into 4 by 3, and in FCC corner spheres are in touch with the face centered sphere. So, face centered diagonal AD, that is this AD is equal to 4 times the radius of the sphere, that is 4r. So, but from right triangle ACD, this right angle triangle AC is equal to AD square plus CD square, that is root of A square plus A square is you will get it as square root of 2 into A. So, 4r is root 2A, A is equal to 4 by root 2r. So, volume you just take the cube of that. So, packing efficiency will be equal to same 4 into 4 by 3 pi r cube into 100 divided by volume is 2 root 2 r the whole cube, just cube these things. 2 cube is 2 cube into root 2 cube, you will be getting 16 root 2 r cube, and here 4 4s are 16 divided by 3 pi r cube into 100. Hope you are understanding. See, what is root 2 cube? Root 2 into root 2, 2, okay, 2 into root 2. So, okay, 2 into root 2 into 2, okay. So, that is how you get the value here. So, just that will be 16 root 2 r cube, which is equal to, when you calculate it, you will get 74%. Calculation side and sum side will solve it in another section, because I do not want to take too much time on this for this particular session. Okay, now unit cell dimension. So, edge of the unit cell of a cubic crystal is found out by X-ray diffraction, that is AD is the density of the solid substance, m is the molar mass. So, for cubic crystal, volume of a unit cell is A cube, then mass is number of atoms into mass of each atom, that is Z into m. So, Z is equal to number of atoms present in one unit cell, m is the mass of single atom. So, mass of the atom present you can calculate it by using the formula m divided by Na. So, density is equal to mass by volume, Z into m, here this Z into m divided by A cube into Na. So, mass is A cube, we found it already. So, volume that is A cube into Na. Okay. So, just substitute it, mass of the unit cell. How many is Z into small m? Small m is mass of the single atom. Okay. And from this you can find out the unit cell, you will get problems on based of it. Just remember, density of the unit cell is Z into capital M by A cube into Na. And now vacancy defect, see that we will explain in the next session. So, you can just see that AB and these are ions, and vacant space is there. How it is formed, we will explain it in our next session. So, we are having again 2-3 more sessions from this unit, and hope you all watch the previous sessions, and do share, support and like our channel Chemistry Made Simple for NEET, and share this with your friends. And I am very happy with your overwhelming response of late. Many students are visiting this site for all the contents which are posted quite free without any fees or charges for you. So, we will be again coming up with a brand new video at the earliest. Thanks for watching.